Hello guys, hope you are doing extremely well. In this video I'm going to explain this problem of the day from LeetCode, and today's problem is partition list. Let's get started. Given the head of a linked list and a value x, partition it such that all nodes less than x come before nodes greater than or equal to x. Alright, it is saying that will be given a linked list and other integer value x, and we will have to make partition in that in two parts. In first part, all the values that are less than this value x will come before, means in the first partition, and all the nodes which have value greater than this given integer x will come in the second part. So we have to make two partition like this, and you should preserve the original relative order of the nodes in each of the two partition, and the two partition in itself will maintain their relative order of the nodes as in given linked list. Alright, now we will see this example 1. 1 is pointing to 4, 4 is pointing to 3, 3 is pointing to 2, and this 2 is pointing to 5, 5 is pointing to 2, and at last 2 is pointing to null. Now this is the given linked list, and the integer that is given to us x is 3 here in this example 1. Now how we are going to partition it? For partition, I will maintain here a pointer for traversal purpose. Let's name it current, and as we have to make two partitions, I am creating here two nodes for creation of two linked list. Alright, and as initially they are empty, so I will create a dummy node as the head of these two linked list, and I will insert any value, let's say 0, to the head of these two linked list. Why I have created these two dummy nodes? Because I want to maintain tail pointer, tail 1 and tail 2, for inserting nodes after these tail nodes one by one in these two given two linked list which I am creating. I will make connections. I will make this t1 to point to the nodes which are less than this value 3 one by one, and let me show you by traversal. First I will come to this node, I will check is it less than 3, yes it is, and all the values, all the nodes whose values are less than 3 will come in this linked list 1. I will make this t1's next. T1 is a tail pointer which is always will remain at the last node of this linked list 1. As there were no node, so I have created a dummy node for it so that it can reside here initially, and this 1 is smaller than 3, it will come in linked list 1. All the nodes which are going to be less than 3, I will insert them in linked list 1. 1 will come here. How I will do this? I will make t1's next is equals to current. Alright, now I will move my current to next node. Now current is larger than this value x. All the values larger than this value x, I will insert them in linked list 2 by using the tail pointer of linked list 2. I will do like this. T2's next now is equals to current, and at the same time I will increase this T2, and previously I should have increased this T1 to this node, T1 here to this node. Alright, now T1 is here at the last node of linked list 1, and T2 is here at the last node of linked list 2, and they will always remain at the last node of the corresponding linked list. Now I will move my current to the next node, and now is 3 less than 3? No, it is not less than 3, so it will come in linked list 2. I will make this T2 next to current node, and I will move this T2 ahead to the next node. Now current will move to the next node. Is 2 less than 3? Yes. Now this current will come here in this linked list 1. So once next will be 2. T2 will move ahead. Now current will also move ahead. Current is now pointing to 5. 5 is larger than 3, so it will come in linked list 2. 5 here, and now I will move this T2 ahead. And now after moving this current ahead, it will come to the last node. And is it less than x? Yes, 2 is less than 3, so it will come at the end of linked list 1 like this. And I will move this T1 ahead. Sorry, it was T1. T1 is here at 2 and T2 is here at 5. Now I will move my current ahead. Now it is pointing to null, so I will stop here as I have traversed whole given linked list. Now I have these two partitions separately. I will connect them as shown is in this example 1. So this partition of linked list 1 will come first 1 2 2, which is containing these three nodes 1 2 2 1 2 2, and then at last these node 4 3 5 will come. Now how I'm going to attach this linked list 2 at the end of this linked list 1. So I will take this tail node of linked list 1 and I will make its next point to the next of head of this linked list 2, which is pointing to 0. I will make to point to the next, because I want the connection to be made with this node which is containing 4, because this 0 is the dummy node. Alright. And one more thing is left here. I have to point it to the null, because initially this 5 node is pointing to 2. Now this node 5 is the last node of our output linked list, so it has to point to null. So I will make it to point to null by doing t2 next is equals to null. Now it is pointing to null. Now I can simply return the head of my linked list 1, and which will give me the whole linked list. But here head is 0, so I will return head ll once next, which is this node. I will return this node, and now all the nodes are present after it, so all nodes after it will get printed. Now let's try to code it as we have discussed. As we have discussed, I am going to make two dummy nodes like this: list node star, and let's name it ll1. And when we are creating a new node, we use new operator, and then again class name list node and the value. And similarly I'm going to create the other node, and I will name it linked list 2. Now these are the currently head of these two linked list, and now I'm creating tails for these two linked list for the traversal purpose. Node star t1, and initially a head and tail will be same as there is only one node, so t1 is equals to ll1, and t2 will be equals to ll2. Now I will traverse the linked list like this. While head is not null, till that point I will keep on iterating in the linked list, and I will keep on repeating this while loop. And each time I will, at the end of the while loop, I will move this head to the next node by doing this head equals to head next. And at each iteration I am going to check whether the current node's value is less than the value x or not. If it is less than x, head's value less than x, then I will insert in linked list 1. In else condition, definitely it must be greater than or equal to x, then I will insert in linked list 2. And for inserting at the end of linked list 1 and linked list 2, I am going to use their tail pointers. So tail pointer next will point to head, that is my current node, and I will move ahead this tail by doing this. So tail automatically will now point to the next node. And similarly I will do for the second case in which I am inserting the nodes in linked list 2. T2 next is equals to head, and T2 is equals to head. So when I am doing this T2 is equals to head, I am just moving ahead the T2 tail pointer to the next node. Now after this while loop I will have these two linked list LL1 and LL2. Now I have to make the connection, and from the end node of linked list 1 I will attach the head of linked list 2. So T1's next will now point to LL2 next. LL2 is pointing to 0 and its next node will point to 4 in this example. Now T2's next, as I have told here, T2's next will now point to null because it is the last node of our output linked list. So I am doing here T2 next is equals to null. Now now we have successfully connected this linked list. Now I can safely return the head of this linked list 1, which is the this node linked list 1 next, LL1 next. Return LL1 next. Now this is it. Now let's try to run it. I have made this W capital. Now running it again. Yes, the given test cases has been passed. Now submitting it. Yes, successfully submitted. This is it for this video. Thank you.